In previous section, you learned how to make a simple list and you learned to work with the individual elements in a list. And in this section, you will learn how to loop through an entire list using just a few lines of code, regardless of how long the list is. So looping allows you to take the same action or set of actions with every item in a list. As a result, you will be able to work efficiently with a list of any length, and including those with thousands or even millions of items. So you will often want to run through all entries in a list, performing the same task with each item. For example, in game, you might want to move every element on the screen by the same amount. In a list of numbers, you might want to perform the same statistical operation on every element. Or perhaps you will want to display each headline from a list of articles on a website. So when you want to do the same action with every item in a list, you can use Python's for loop. So let's say we have a list of magicians' names and we want to print out each name in the list. We could do this by retrieving each name from the list individually, but this approach will cause several problems. For one, it will be repetitive to do this with a long list of names. Also, we'd have to change our code each time the list length changed. So using a for loop avoids both of these uses by letting Python manage these uses internally. So let's use for loop to print out each name in list of car models or car makers. So car makers here, and we will use the BMW, or Kia here, Ford, Dodge here, Dodge, and we will also use, for example, BMW, Kia, Mercedes, or it was, yes, Mercedes, and Volkswagen, and so on. So now that's enough actually. So 0, 1, 2, 3, 4, 5 on index and 6 items. So we begin by defining list, and now we will write our for loop. So for cars or makers, you can do here makers. You will understand what these makers or cars are. Instead of using makers plural, we can use one here. So car in car makers, and after that we will use double dot here and we will print the car. That's it. So now I will explain all of this code here. So we begin by defining a list, just the regular list, just as we did in previous lectures, and as you can see here, it's car makers. So let's, instead of using red, I can also use another color here. So we define the list of car makers, and here the next we tell Python here, and also firstly here we have for loop. Look at this. So this line tells the Python to pull a name from the from the car makers and associate it with the variable car, right? So, and next we tell the Python to print the name that has been assigned to car here. So here, as you can see here, we printed each of line this BMW, Kia, Ford, Dodge, Mercedes, and BMW in separate print functions here. So, and Python repeats these last two lines once for each name in the list. It might help to read this code as for every car maker in the list of car makers, print the car maker's name, right? So the output is going to be this, as you see here. So now let's take a closer look at this loop here. So looping is important because it's one of the most ways a computer automates repetitive tasks. For example, in a simple loop like we used in this Python here. So Python initially reads the first line of the loop, which is for car in car makers. So this tells Python to retrieve the first value from the list car makers and associate it with the variable car, right? So this first value is here BMW, and Python rates the new line here, and Python prints the current value of the car makers, which is BMW, because the list contains more value. So, and Python returns to the line of the first loop. So now Python retrieves the next name in the list, which is Kia here, Kia, and associates with the value with the variable magician. So here we have firstly in first loop here we had BMW, secondly we had Kia here, in third loop we had Ford, and here Python prints the current value of car again, which is now Kia, right? And Python repeats the entire loop once more with the last value in the list. In this case, Ford, and then Dodge, Mercedes, and lastly Volkswagen. And after that, we are ending this loop, and here we printed all the loop. So when you are using loops for the first time, keep in mind that the set of steps is repeated once for each item in the list. So no matter how many times items are in the list. So if you have 1,000,000 items in your list, Python repeats these steps 1,000,000 times, and usually very quickly. And also keep in mind when writing your own for loops that you can choose any name you want for the temporary variable that will associate it with each value in the list. You can do, for example, my car make or so on. And of course you have to change the my car make here. That's it. However, it's helpful to choose the meaningful name that represents a single item from the list. For example, instead of doing cars here, writing this for cars in car makers, or for dogs in dogs, you can write for dog in dogs here, or for cat in cats, because this first item represents just one item, but here this represents the list in this case. The naming conventions can help you follow the action being done on each item within a for loop. Using a singular and plural names can help you identify whether a section of code is working with a single element from the list or the entire list. You can do just about anything with each item in a for loop. Let's build on previous example by printing a message to each car makers, telling them that they performed a great model, or let's actually tell them that what their models and great car. Let's actually, instead of telling what they are, let's provide just a great car, right? The only difference here we will make, so I will tell you right now, in this code we will compose a message to each car make, starting with the car makes make, right? So in this we will print this, we will use the format again, and the car, oops, not like this. Here inside this format we will car make and title, and this was a great car, great car. And after that, let's print this out. And as you can see here, the only difference in this code is where we compose a message to each car model, starting with the car model's name, and after that we are telling our message. So the first time through the loop, the value of car make is BMW. So Python starts the first message with the name of BMW, and the second time through, the message will be the Kia here, right? So and here, as you can see here, the Kia, and the third time through, the message will be Ford. Fourth time is going to be Dodge. The fifth time is going to be Mercedes, and the sixth time is going to be Volkswagen. So you can also write as many lines of code as you like in the for loop. Every intended line following in the line for car make and car makers is considered inside the loop. So here this is the outside the loop, But if we write the tab here, and this is inside a loop, so it will loop inside here every time our loop works. So therefore you can do as much work as you like with each value in the list. So let's add a second line to our message telling each car makes that we are looking to their next trick. And now in order to do that, we will use this inside here. So we will print this again. We will use the format, and cars are great car. And now we will something car here. So now we will do this, that BMW or MPG is high on, or let's actually miles per gallon, and yes, miles per gallon is high on this car. For example, in this case we will use car make. And now let's run it, and as you can see here, the BMW great car, miles per gallon is high on BMW. Kia great car, miles per gallon is high on Kia. Ford great car, miles per gallon is high on Ford. And here, because we indented both cars to print here, each line will be executed once for every car make in the list. So the new line, let's actually use the new line here and see how this output will change. And as you can see here, a new line in the second print calls insert a blank line after each pass through the loop. So this creates a set of messages that are neatly grouped for each car make on the list. So now let's run this list here. So this is our first iteration. So this is our first loop, second loop, third loop, fourth loop, fifth loop, and sixth loop. And here our loop ends because we do not have any item into the list, and that's why our loop breaks here. That's it. So oops, let's actually fix that. And here, that's it. So here you can use as many lines as you like in your for loops. In practice, you will often find it useful to do a number of different operations with each item in a list when you use a for loop. What happens once a for loop has finished executing? Usually you will want to summarize a block of output or move on to other work that your program must accomplish. Any lines of code after the for loop that are not intended are executed once without repetition. So let's write a thank you to group of car makers as a whole, and thanking them for putting on an excellent cars. So to display this group of message after all of the individual messages have been printed, we place the thank you message after the for loop without the indentation here. So now we will write print thank you every car makers. These cars are special and great. And here, now let's run this, and you will see this message is just executed once. So the first two calls to print are repeated once for each car makers in the list, as you saw earlier. However, because the last line is not intended, it's printed only once. If we add indentation to it, you will see, as you can see here, thank you every car makers, thank you every car makers, thank you every car makers, and so on. So we will delete this indentation, and we will get this thank you message only once because it's not included in this loop because of the indentation we didn't put before the print here. So when you're processing data using the for loop, you will find that this is a good way to summarize an operation that was performed on an entire dataset. For example, you might want to use a for loop to initialize a game by running through the list of characters and displaying each character on the screen. You might then write some additional code after this loop that displays a play now button after all the characters have been drawn to the screen. Python uses indentation to determine how a line or group of lines is related to the rest of the program. In this examples, the lines that printed messages to individual car makers were part of the for loop because they were indented. So Python's use of indentation makes code very easy to read. Basically, it uses white space to force you to write neatly formatted code with a clear visual structure. In longer Python programs, you will notice blocks of code indented at a few different levels. These indentation levels help you gain a general sense of the overall program's organization. So as you begin to write code that relies on proper indentation, you will need to watch for a few common indentation errors. For example, people sometimes indent lines of code that don't need to be indented, or forget the indented lines that need to be indented. So seeing examples of these errors now will help you avoid them in the future and correct them when they do appear in your own programs. So now let's examine some of the more common indentation errors. So you can also forget the indent. Always indent the line after the for statement in a loop. If you forget, Python will not remind you here. And as you can see here, expected an indented block. So here, if we write, for example, car makers, and let's split this indentation, get an error also. So let's actually delete this and I will explain all of this. So the call to print should be indented. So, but it's not here. So when Python expects an indented block and doesn't find one, it lets you know which line it had problem with. And if we run this code again, and let's run here, and as you can see, we have an indentation error as line 3. So you can usually resolve these kinds of indentation errors by indenting the lines or lines immediately after the for statement. You can also forget to indent additional lines. So sometimes your loop will run without any errors but won't produce the expected result. So this can happen when you are trying to do several tasks in a loop and you forget to indent some of its lines. For example, this is what happens when we forget to indent the second line in the loop, and here we will not get any error here. And now if we run this, and as you can see here, list object has no attribute title. As a result, the first print, and if makers here, this code will, and as you can see, let's car make. This code will run without a problem. We just edit this, and if we change this to car make, and we will get this as well. So here, as the result here, the first printf call is not indented, and so that's why first print call is executed once for each name in the list because it's indented. But here the second print call is not indented So it's executed only once after the loop has finished running, because the final value associated with Volkswagen here, and Volkswagen is the only one who receives the who receives the thank you every car makers. These cars are special and great, and Volkswagen only one who gets the miles per gallon is high on Volkswagen. And here, this is a logical error. This syntax is valid Python code, but the code does not produce the desired result because a problem occurs in its logic. So if you expect to see certain action repeated once for each item list and it's executed only once, determine whether you need to simply indent a line or group of lines. So here, that's now we are getting this error here because in for loop, if you have a for loop here, for now, this print message will execute at once, but your program firstly execute your for loop again, and again, and then after completing the for loop, it will go to next lines here. Many reasons exist to store a set of numbers. For example, you will need to keep track of the positions of each character in a game, and you might want to keep track of players' high scores as well. In data visualizations, you will almost always work with a sets of numbers such as temperatures, distances, population size, or altitude, longitude values, among other types of numerical sets. So lists are ideal for storing set of numbers, and Python provides a variety of tools to help you work efficiently with lists of numbers. So once you understand how to use these tools effectively, your code will work well even when your list contains millions of items. So you can also use the range function. So Python's range function makes it easy to generate a series of numbers. For example, you can use the range function to print a series of numbers like this for my value here in range, for example, from 1 to 10, and here we will print my value. And here you will see, and here you will see range from 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So although this code looks like it should print the numbers from 1 to 10, it doesn't print the number 10. In this example, range prints only the numbers from 1 through 10. So I want to explain this by drawing something on the screen here like that. For example, this is range here. For example, we wanted variable 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and 10. Here when we ask range for a number from 1 to 10, it will give us from here and from 1 to 9. So this is the number this code will give us here. So as I said, in this code, the range prints only numbers from 1 through 10, through 9. Let's run it again. And here, so this is another result of the off by 1 behavior you will see often in programming languages. And the range function causes Python to start counting at the first value you give it, and it stops when it reaches the second value you provide. Because it stops at the second value, the output never contains the end value, which would have been 10 in this case. To print numbers from 1 to 10, you will do this. Just 11, write 11, and that's it. Here, as you can see, we printed values from 1 to 10. So if your output is different from what you expect when you are using range, try adjusting your end value by 1. So you can also pass range only one argument, and it will start a sequence of numbers at 0. For example, range 6 here will return the numbers from 0 to 6. So you can also use the range to make a list of numbers. So if you want to make a list of numbers, you can convert the results of range directly into a list using the list function. So when you wrap list around the call to range function, the output will be a list of numbers. In this example, the previous section, in the example of previous section, we simply printed out series of numbers, and we can use list to convert that same set of numbers into a list. So in order to do that, we will do numbers, or my special numbers, my special numbers equals list here and range 116 or 111 here. So now we have to add here, and we will add, after that we will print the my special numbers. That's it. Here you can see the 1 2 3 4 5 6 7 8 9 10. So we can also use the range function to tell Python the skip numbers in a given range. If you pass a third argument to range here, Python uses that value as a step size when generating numbers. For example, here's how I list the even numbers between 1 and 10. We will do here 2, and we will do 2 here again, and here, and as you can see here, 2 4 6 8 and 10. So in this example, the range function starts with the value 2 and then adds 2 to that value. It adds repeatedly until it reaches or passes the end value 11. I want to also illustrate this on screen here. So here we have 1 2 3 4 5 6 7 8 9 7 8 9 10 here. So here what you see is, so here we are saying that we will start from 2 and end from 10 11, but this means 10 here, as we explained here. So we will start from the 2 here. So we will start first from this 2 4, because as you can see here, we are passing 2 in each number, and then we come here, and here we go to 6, and here we come here, and here we go to 8, and here we are, and then we are going to 10, and this is where our range ends. So you can create almost any sets of numbers, or you want to use the, so you can also create, you can create almost any set of numbers you want to using the range function. So for example, consider how might make a list of the first 10 square numbers, that's the square of each integer from 1 through 10 in Python, which is 2 asterisks like that. So let's actually close this. So now here's how you might put the first 10 square numbers onto a list. So here we have a my special, or my squares here, squares, and here we will create an empty list. Now we will use the for loop, my value here in range, and here we will start from 1 to 11, and here we will use the my squares here equals my value asterisk 2, and dual asterisk here, and 2, and here we will use my squares here that append or my value here, here my squares that append or my square here, and we will change it, my square equals my value asterisk 2, and here we will use my squares that append the my square, and that's it. And after that, of course, we will need to print the squares here, but outside the for loop, as you can see here. We are printing outside the for loop. Squares here, or my square. Yeah, that's it. Now let's run it. And as you can see here, 1, 4, 9, 16, 25, 38, 49, 64, 81, and 100. So we start with an empty list called squares here. Actually, let me here. So here we start with the empty list called my squares. Here, let's actually use that marker. So here we start with the empty list called my squares. Then we tell Python to loop through each value, from 1 to 10. In this case, we write 11 using the range function. So inside the loop, the current value is raised to the second power and assigned to the variable my square here. Each new value of square is then appended to my square list here. As you can see here, we are using append here. So this works like that. For example, this is our my squares here, and here we added, and then another loop comes, we added another value, and then another loop comes, we added another value inside it, and until the 10 times here. So that's it. And finally, when the loop has finished running, the list of squares is printed on the screen. In previous lectures, you learned how to access a single element in a list, and in this section, you've been learning how to work through all the elements in a list. So you can also work with a specific group of items in a list called a slice in Python. So to make a slice, you specify the index of the first and last elements you want to work with. As with the range function, Python stops one item before the second index you specify. The output of the first three elements in a list you will request here indicates truth 0 to 3 here. So now if we write 0 to 3 here, we will get this here, and this is our slice. So here I will create some examples here. So let's again make some example about car makers, or let's sometime now yeah car makers is okay. Car makers, here we will add BMW, Honda here, we will add Volkswagen, we will add the Ford, Hyundai, Kia, and Nissan here. So here we will print the 03. So print car makers 03 here. So this code now this code prints a slice of the list. So the output retains the structure of a list and includes the first three car makers in the list here. So in this case, it's gonna print us here. It's gonna print us BMW, Honda, and Volkswagen. So it will print us these three items since we write 0 and 3 here. So now let's print this, and as you can see here, BMW, Honda, Volkswagen. So you can generate any subset of a list. For example, if you want to second, third, and fourth item in a list, you will do this. Here, as you can see here, we started Honda, Volkswagen, and Ford. And this time the slide start with Honda here and ends with the Ford. So if you omit the first index in a slice, Python automatically starts your slice at the beginning of the list, like this here. You just need to add this double dot here, and as you can see here, we got BMW, Honda, Volkswagen, and Ford here. So a similar syntax works if you want a slice that includes the end of a list. So for example, if you want to
all items from the third item through the last item, you can do this. 2 double dot, but this double dot here will come after the number to get the last item. So here, get from the last item. Now in this case, we will get, as you can see here, it's actually, where's my marker? Yes. So here we got Nissan, Kia, Hyundai, Ford, Volkswagen, and that's it. We got from here to here. So we got 2 here. We counted 0, 1, second, and from second we told Python that get all those items from the last. So Python returns all the items from the third item through the end of the list. Volkswagen, Ford, Hyundai, Kia, Nissan. So this syntax allows you to output all the elements from any point in your list to the end, regardless of the length of the list or something. So recall that negative index returns an element a certain distance from the end of a list. Therefore, you can output any slice of the end of a list. For example, if you want to output the last 3 car makers on the car makers, we can use this slice like this here. -3, -3 here, and this double dot here, and after that we will print this. And as you can see here, we printed Hyundai, Kia, Nissan here. So you can include a third value in the braces, indicating a slice. So if a third value is included, this tells Python how many items to skip between items in the specified range. So you can use a slice in a for loop if you want to loop through the subset of the elements in a list. So in this example, we will loop through the first 3 car makers and print their names as a part of a simple car maker. Now we will print here. Here are the first 4 car makers in my list here, and after that we will use for loop for car maker in car makers, and here we will enter this. Here for, and after that we will print here. We will print the car maker dot title. So here we will, let's run this, and as you can see here, we got this example. We got this output. So instead of looping through the entire list of players or car makers, Python loops through only the first 4 car makers. So slices are very useful in a number of situations. For instance, when you are creating a game, you could add a player, you could add a car maker's model to a list every time that that car is running or playing, the player is playing with that car. So you could then get a player's top 3 scores by sorting the list in decreasing order and taking a slice that includes just the first 3 scores. Often you will want to start with an existing list and make an entirely new list based on the first one. So let's explore how copying a list works and examine one situation in which copying a list is useful. So to copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index, like this, right? So this tells Python to make a slice that starts at the first item and ends with the last item, producing a copy of the entire list. For example, imagine we have a list of our favorite car makers and want to make a separate list of car makers that are friend drives. So this friend likes everything in our list and drives everything on our list so far. So we can create their list by copying ours. So in order to do that, you will write friend that likes cars, and here we will use this, and let's actually my favorite cars, and here friend's favorite car, and here now we will use this my favorite cars and this, and after that we will firstly print this friend's favorite cars, and after that firstly, of course, this is the friend's favorite cars and this is my favorite cars, and after that we will first print the my favorite cars. So print my favorite cars are like this, and after that we will print our my favorite cars, and after that we will print, of course we need to add a new line before it. So my friend's favorite cars are here, and after that we will print friend's favorite cars, and here we will run this now, and as you can see this is our output. So I added this new line here. Oops, sorry, again it's not working, or yes, it's working now. Okay, so here I added this new line character to this to show our output new line here. So I could be added this new line after the my favorite cars here, but it's more easy to add here instead of writing some formatting and things in last my favorite cars print function. So first we make a list of car makers we like, called our favorite car makers, called my favorite cars. Then we make a new list called friends favorite cars, and we make a copy of my favorite cars by asking for a slice of my favorite cars without specifying an indicator like this here, and assign the copy of my favorite cars to friends favorite cars. So when we print each list, we see that they both contain the same cars. So to prove that we actually have two separate lists, we will add a new car to each list and show that each list keeps track of the appropriate person's favorite car. So in order to do that, we will do after my favorite cars here, we will do my favorite cars that append here. Let's add new car maker name. In this case, Toyota, right? So Toyota. Oops. Toyota here, and after that we will also add friends favorite cars, and we will append the let's add Fiat, right? And here we will not change this print functions, and now we will run our code and see what will change here. And as you can see here, so we copy the original items in my favorite cars to the new list called friends favorite cars, as we did in the previous example. And next we add a new car maker to each list, and we add Toyota to my favorite cars, and we add Fiat to friends favorite cars, and we then print the two lists to see whether whether each of these favorite cars is in the appropriate list. So here the output shows that our Toyota appears in our list of favorite cars, but Fiat does not. So we can see that fiat now appears in our friends list, but Toyota doesn't, right? If we had a simply set friend's favorite cars equal to my favorite cars, we will not produce two separate lists. For example, here's what happens when you try to copy a list without using a slice. Oops. Without using a slice. And as you can see here, we both have fiat. So instead of assigning a copy of my foods to my favorite cars to my friend's favorite cars, we set a friend's favorite cars equal to my favorite cars. So this syntax actually tells Python to associate the new variable to my favorite cars with a list that is already associated with my favorite cars. So now my favorite cars, it will also appear in friends' favorite cars, and so on. So likewise, the Toyota will appear in both lists, even though, or Fiat will appear in both lists, even though it appears to be added only to my favorite cars. And as you can see here, Toyota and Fiat appears in the same list. So the output shows that both lists are the same now, which is not we wanted here. And don't worry about the details in this example for now. If you are trying to work with a copy of the list and you see unexpected behavior, make sure you are copying the list using a slice, as we did in this in the first example here. Lists work well for storing collections of items that can change through the list of a program. So the ability to modify lists is particularly important when you are working with a list of users on a website or a list of characters in a game. So, however, sometimes you will want to create a list of items that cannot change. So tuples allows you to do just that. So Python refers to values that cannot change as immutable, and immutable list is called tuple. So a tuple is just like a list, except you use parentheses instead of a square braces. Once you define a tuple, you can access individual elements by using each item's index, just as you would for a list. For example, if we have a rectangle that should always be a certain size, we can ensure that its size doesn't change by putting the dimensions into a tuple. So my dimensions here, we will add 250 here and 100 here, and here we will print first we will print dimension 1, and then we will print oops, not like that. Of course we need to get a variable name. So my dimensions 1 here, and here, as you can see here, we define the tuple dimensions using the parentheses instead of a square braces like we did in lists. So then we print each element in the tuple individually using the same syntax we have been using to access elements in a list. And as you can see here, we first printed 250 and 200 after that. So and actually let's see what happens if we try to change the items or change one of the items in the tuple dimensions. Now here we will write my dimension. Actually, let's name it my tuple, right? So it will be more explanatory. My tuple dimensions, and here we will use the my tuple dimensions equal 0. Let's make 0 to 150 here, and after that print this my tuple dimensions 0, and after that print my tuple dimensions 1. And here, so this is the error we got here. Actually, delete this for now. So this code tries to change the value of the first dimension, but Python returns a type error because we are trying to alter a tuple, which can't be done to that type of object. And Python tells us we can't assign a new value to an item in a tuple here. As you can see here, tuple object does not support item assignment. So this is beneficial because we want to Python raise an error when a line of code tries to change the dimensions of the rectangle. And tuples are technically defined by the presence of a comma. So the parentheses make them look neater and more readable. So if you want to define a tuple with one element, you need to include trailing comma here. So if you want to define tuple just one element, you need to include this trailing comma. Yeah, so it doesn't often make sense to build a tuple with one element, but this can happen when tuples are generated automatically. So you can also loop through all values in a tuple. So you can loop over all the values in a tuple using just a for loop, just we did in previous lectures with lists. So here now we will add new tuple. So my tuple or my car models, my favorite car models that I will like forever. And this is not the best name for that, but this is general explanatory purposes. And here we will add tuples that, for example, I like BMWs, I like here, for example, I like Volkswagen, but the sporty ones. Here I like Fords here. So that's it, Ford. And here we will loop through all the tuples in this list. So remember, this is not a list. This is actually, let me here. So remember, keep in mind that this is not a list. This is tuple. This is tuple here. So here we will loop through all the items in this list. So for my fave car, and here we will do in my favorite car models that I will like forever. And here we will print here my fave car, and let's print this. And here, as you can see here, we loop through all the elements here. So Python returns all the elements in a tuple, just as it would for a list. So although you can modify a tuple, so that's it, how this works here. So although you can't modify a tuple, you can assign a new value to a variable that represents a tuple. For example, if you wanted to change the dimensions of a previously created rectangle dimensions, here, for example, 250 and 100, and we will print the original dimensions here, original dimensions here, and after that we will create a for loop, dimension in dimensions, and after that we will print here, we will print the dimension, and here we will, after that we will do again dimensions. We will change the dimensions here, dimensions, and equals, for example, 500 and 200, right? And after that we will print this new line, modified dimensions, and here we will create a new for loop. Actually, let's use double dots here, make it look nicer, right? So for dimension in dimensions, and here we will print dimension again. That's it. And here we will, let's run it. That's it. And here, this is our output. So the first 4 lines defines the original tuple and print the initial dimensions. And we then associate a new tuple with the new variable dimensions and print the new value. And Python doesn't raise any error this time because reassigning a variable is valid. So when compared with list, tuples are simple data structures, and use them when you want to store a set of values that should not be changed throughout life of a program.